this is a DevOps CI/CD project. So CI/CD means continuous integration and continuous deployment. So continuous integration means a large team of developers is working on one project. So all of them continuously integrate their updates and changes in one place. So that part is taken care of by Git and GitHub. So on a local level, developers can integrate their changes on their local machines using Git, like creating different branches and merging them. And then on a remote and broader level, the developers can push their code into the common uh, remote repository, and and their changes can be integrated in this repository, such as by merging pull requests. So this is a very simple project. It's a static web page linked to a image. So we are going to assume that continuous integration has already happened, and now we will look at the continuous deployment. How do these changes automatically, as soon as they happen, they get deployed to production? So for this, GitHub has a feature. It's called webhooks. So they allow, so whenever an event occurs here, such as a push or any other kind of event, we can select that. GitHub Webhooks, this is a service. So it will send a notification to an external service, which in our case it will be our Jenkins. So GitHub will send a notification to Jenkins that the repository has been updated, and as a result, Jenkins will start its build job. Jenkins will start this job, and it will deploy the project on an AWS EC2 instance. For this to work, Jenkins must be exposed to the internet because GitHub needs the URL of the external service. We can't just provide localhost 8080. So for this we will use Ngrok to expose this to the internet. And this is the fixed URL I have for Ngrok. So this is how the job looks like. We have a GitHub project. Actually, this is not really needed here, but anyways, we have a GitHub project. This is the URL, simply the repository URL. Here we have under source code management. Here we need to configure Git with the URL, and these credentials are not needed because this is a public repository. If this was private, then you will need credentials, and the credentials means the username of the GitHub user, and instead of the real password for your GitHub, you use a personal access token. So you can get one through this. Just I use the classic token. Yeah. So like we just generate a new token, classic one. So here you can set expiry date and also scopes. So I just use this public repo scope so it can access my public repositories and usually just read access to everything. So it should be able to read the hooks also. This is for Jenkins. So after this you can just generate the token and it will appear here. Then you can copy it and paste it in your Jenkins. So this is the credentials for Git. So here under triggers we need to check this thing. For this we need the GitHub plugin first for Jenkins. So GitHub hook trigger for Git SCM polling. So this will allow Jenkins to identify when GitHub sends a notification from here. So Jenkins will be able to detect that now is the time to trigger this job. In the environment, I'm deleting the workspace before the build starts. It's better to do it this way. Then we are using some secret text or files which are defined inside of Jenkins. So we need Docker Hub credentials to upload the Docker image to Docker Hub, and these credentials you can get from so this is my Docker Hub, and you go here, personal access token again. So you can generate a new one from here and then you can copy and paste in Jenkins. Then we need two secret texts called AWS access key ID and secret access key. The name of this variable should be exactly this, in caps and with the underscores. Because Terraform needs to use these and it only accepts these two names. So this is the AWS console. We will switch the region to India. So these two keys are made for an I am user. An I am user. So this Jenkins is using the keys for an I am user, and that I am user has a few permissions attached to it. So it can perform those actions. This is the I am user that I am using for Jenkins on my laptop for the local host. So it has these access keys. This one I created just to test. And it has these permissions. So everything is full access. So it can read, write, delete everything. So it needs EC2 full access to create an EC2 instance and it needs S3 full access to store Terraform's state in the S3 backend, and it needs ECR full access because in the middle I switched from storing the image in Docker Hub to storing it in ECR. And then it needs IAM full access to pass an IAM role to the created EC2 instance so that that instance can pull the image from my ECR repository. So if I was using just Docker Hub, this would not be needed. So because I'm using ECR, I need this also. Plus, we need something more, some more specific. It needs so this I generated with the help of AI. So this is a specific policy. So, so you need a policy to be able to pass a role to the EC2 instance, but to be able to pass an IAM role to it. So you can, this IAM pass role, this thing is not available in any of the default IAM full access policies. So we need to create it ourselves. So these two keys are pasted here. Then ECR. So these two variables are used in a command to fetch login credentials for Docker Hub. So Docker Hub will redirect our uploaded image to ECR instead of Docker Hub. So ECR user is just AWS. ECR password is it's not a password. This is the ECR password. It is your account ID and then your region and this thing. So it's not really a password. Then we come to the build steps. So first thing we will do is build the Docker image. So this is the full name of the image, the name and the tag. And here dot means the Docker file which is used to build this image is found in the current directory. Otherwise this is the path to the Docker file. So we can see in our project there is a Docker file just in the root. So we are using Nginx Alpine version. Nginx will serve our static website. Then we copy our files into this directory. So Alpine makes it a compressed file, compressed image. And then if I want to push this image to Docker Hub, I will need to also tag it like this. My Docker Hub username slash the image name. But here I'm pushing it to ECR. So I'm using this AWS. This is an AWS CLI. You have to install it. And this command will give me this command will give me the actual password, temporary. It will expire in 24 hours or something. So a temporary password to use ECR in my account, and I am piping this output to the Docker login command. Where here the username is AWS and password is an input field. That URL is already here. Whatever this command gives me will be attached after this URL. So that will be the full password. Then if I want to upload this image to ECR, there is a specific way to tag it. So I'm tagging it like this. The URL of the ECR slash this thing, AWS test first repo, the path to the repository. Then I'm just pushing it, referencing it by the new ECR tag. So once that is done, I'll go in the Terraform directory, initialize it. Force copy means if there is a remote state already existing in the S3 bucket, then it will fetch that state into the local directory. And if no remote state exists, then it will create a local state and upload it to S3. And then I'm applying it and replacing just the AWS instance. Auto approve means all the yes things that we need to type Y for. It will auto approve that. So you only need this one command for your continuous deployment. So if no infrastructure exists in my AWS account, then this command will create everything. But after the first time it created everything, then another push occurred in my project. Then it just needs to replace the AWS instance because that is where the project is running. So on the next time this is done, it will just replace the AWS instance. So I have linked, uh, so the GitHub webhook will be delivered to this command. So now I am starting the Ngrok tunnel to my Jenkins. With this, I got this free URL from Ngrok, so I can permanently use this. So we can simulate what would have happened if we had got a webhook, if we had got a push. So this is how it looks. It has all the info about the latest commit. So I can just redeliver this notification. This was successful. In Ngrok we can see 200 OK response, but the job didn't start automatically. Sometimes this happens, so we need to start it manually once. After that it will run automatically. And we need to have Docker desktop running for this, because that's how it will create the Docker images. That's how it will be able to use the Docker command. So this was successful. In the output we can see that it fetched the changes from our GitHub. So it executed Docker build, Docker tag, all the build steps were executed, login succeeded for ECR. Now it is pushing to our ECR. So it pushed successfully. It initialized Terraform. It outputs a plan by default. So 9 resources need to be added, because right now nothing exists on AWS. So apply complete, it added the 9 resources, and we defined some outputs in our Terraform file. So it outputs the ID of the instance and the IP address of the new instance. So you can see this DevOps instance is the name of the instance. The name of the instance is DevOps instance, and it is created and running here. So if we visit its public address, I have mapped the, so by default Nginx exposes port 80 as the public port to serve our website, but uh, the container which is running on this EC2 is mapping that 80 port to 9090 of the machine of the EC2. So if I go here, it shows me the welcome page and I can access all my files from here. So this is the static website with the linked image. So this is working. So when the instance got created, it ran this script. So it uses the yum package manager. It installed Docker, and we go, we run the same ECR command to get the login credentials. Then we pulled the image from ECR and then we ran it like this. So D means detached mode. So the terminal which invoked this command can be closed and the container will be running in the background. P means the port mapping. So our machine port maps to the image port. So 9090 maps to 80. And this is the name of the image we want to run. So it executed the script. And it has a security group rule also. So we are allowing ingress on only these two ports. 22 is SSH, 9090 is where our application is exposed. So we are allowing from all IP addresses. Anyone can access this. And egress we are allowing for all the ports to anywhere. And we also need a key pair, a public private key pair. So this is the path to the public key file on my desktop. And I also have a private key which does not have the .pub extension. Using the private key, I can use SSH to connect to this newly created instance because it has this public key. So how to generate this? There is a command called SSH keygen. Using that we can generate a key pair like this. So if I want to connect to this instance using SSH, I will replace this with my private key. So it will ask whether you want to allow this because it doesn't know whether it is authentic or not. Yes. So here we are in the terminal of the newly created EC2 instance. And if I see the currently running containers, we have one container and this is the image which it is running. This is also the ECR password in Jenkins. So our image was correctly fetched and it is now running, and this is the port mapping. So we are doing here we are running an important command. We are adding EC2 user to the Docker user group. So this will allow easy to user to run Docker commands without using sudo, because the Docker daemon, the service Docker, automatically binds to the root user. So any other user trying to use Docker will need to use sudo. So now I also have a job to delete this. So it is very simple. No need of any hook, but it does need source code management and no need for credentials. So there is just one command, terraform init and destroy. So it will just delete everything, all those 9 resources. We have to build this manually. But it was successful. So first it refreshes the state. It fetches the state file from the S3 backend to know what all it has already created, which it needs to destroy. Nine to destroy. So there are security group rules, there is a key pair, there is a IAM role, then there is the instance. So there are 9 resources total. So it destroyed all of them. This instance has been terminated. Now we can't access it anymore. So now if I make an edit, and I commit it, you can see as soon as I committed it, this Jenkins job automatically started, because once again a notification was delivered through GitHub Webhooks. So this was successful. So we have the new DevOps instance, which is now running. it takes some time for it to run the script to install Docker, uh, get the ECR password, pull the image, create a container and run it. Now, now we have the edit, and now one more use case. Without destroying the current infrastructure, this command can just replace the AWS instance. So if I make one more commit, so I committed it. Now this job has started again automatically. So this was successful. So first it refreshes the state. So it recognizes that all of this is already there. So it will destroy and then create the replacement. One to add, zero to change, one to destroy. So first it will destroy our existing EC2, then it will create a new one. So it created the new one. So now there are three instances. Two of them are terminated. This is the latest one, which is running. And this will have the new message from the intern. Here is the new commit. So it just replaced the EC2 instance. So I'll just delete everything. So it destroyed everything. all are terminated.